now that the rest of the class has joined us after their dinner snacks, we can go ahead and get started. If you don't have your exam back yet, we will try to hand them out throughout class. Exam answer key is posted. Hey y'all, I know we're arriving a little late, but can we gather together and get started? Answer key is posted. The exam itself is posted, so if you, before the final exam, wanted to try to retake the exam as some practice problems, you can do that for people who wanted to see it without the answers. That's also true for exams 1 and 2. I have the exam posted and the answer key posted. I'm not going to say it's the best study tool you'll ever have because you've already taken that test, so you already know the questions, but it might be one study tool you choose to use. Tonight's class is going to be focused on concentrations and solution chemistry. So this is all about things that are going to be related to your labs that you've started this week, so hopefully you'll find some synergy between them. Any questions about the course? I feel like there might be some questions. No? You're all right? Okay. So, go ahead and if you have not already, please answer this question. Which one of these is not a possible unit to express concentration? All right, I assume that means we're all in. All right. We'll close this out. So we got to mix the results, but a majority of class thinks that D is not an appropriate answer. Why is that? Let's hear from a lot of different voices today. So we'll go ahead and start with Crystal.
Well, I had to take a note from the primer. That's how I honestly answered it. I knew that moles of solid over grams of solid was not the ones that we were looking at.
Okay, so we haven't seen that set of units before, is one of the ways. Why else? Chris?
Because both the numerator and denominator are solutes, and that doesn't tell us anything about the concentration.
Great. So concentration is all saying, what's the relative amount of the thing you dissolved in the thing it's dissolved in? And so if we're talking about what is dissolved in, this is not very useful at all. What would this ratio be called instead? The ratio of moles to grams of a substance. Anyone know what that conversion factor is?
That's our buddy.
So it is a conversion factor, but it is not a conversion factor about when something's dissolved. One and the other. So in your book in chapter 9.4, actually I don't know if the chapter is 9.4, it's table 9.4, I think it's 9.6 in your book, is a whole part of the chapter based on solutions. Hopefully you've gone into that some with your primer. But these are the ones that we're going to be using. Specifically, the ones that were in your primer, and that we're going to spend the most time with, is percent mass, percent volume, percent mass volume, and molarity. I've put this table on the back of your worksheet because some of the units that we're going to use, I'm going to ask you to find the value, and you're going to have to figure out what the right units are for that. If you'll notice, if we're using percent mass, it's going to be typically grams per gram. Grams of solute per grams of solution. Volume, it doesn't matter what your unit is as long as it's the same on the top and bottom. It can be liters and liters, milliliters and milliliters. Somewhere it's literally on the bottom of your worksheet. Sorry, didn't mean to call you out. All right. But then this one is really particular. Mass to volume, you're always going to have grams of solute per milliliters of solution. So let's keep those in mind. By the end of today's class, I want you to be able to take a concentration and use that as a conversion factor. Do it really efficiently. So that means that if we want to know the amount of solute for a given amount of solution, we can do that if we know the concentration. That's true for molarity, percent mass, percent volume. And then we're not going to do too much with mass to mass ratio, but you will see some of that. And then based off of that, I want you to be able to calculate if you want a certain quantity of solute, how much volume do you need? Or the other way around. So let's do some problems. So we're going to start out with on question 2. I want to know what the percent of the solution is. The solution you're seeing here. And why don't you write down on your paper how you calculate that? Please include all units. That way when we're walking around, we can help. Think in the right direction.
So you guys playing the malls? Yeah.
I would convert it for 2/4. No, this is not dimensional analysis. This is unique.
Oh, wait, my bad, it's not 22.6, it's actually...
Would you get 2.276?
Oh, no, it forces me. Okay, so now we show this is equals to 25 milliliters. I mean, it's not as simple as just dividing 86 by 25. Because if you look at the chart in the back, it says, it says grams to milliliters, so that's why it needs to be 56.1 grams over 200 milliliters. If you just divide it out, to 76. And hopefully that's the correct. I played one on PC. Because I think so much about what I think is right. I think so much about like when I think it's right that getting it right confirms it. And then that helps me learn that, okay, this is the correct way. Instead of like failing and then like being confused as like which one is wrong. Like, which one of all these things that I thought was right. How many sequels do you want us to do?
It's not up to me to decide. It's up to the problem to decide.
Oh, okay. Okay, alright, I see.
Alright, we have 28 responses.
Whoa.
And we're closing jump all out.
Well, which question is this?
Oh my god.
Okay, I
I
got it.
feel like
I'm stressed.
clickers are great, unless you get stressed, and then they're maybe not so great. Okay, I'm not going to close it out. We're going to work through it together before I close it out. Okay?
I ended it regardless.
So here is the take home of the night. Write out your units. If you don't write out your units, then all of this is going to be so muddled and confusing. So the first thing I would do here is, what is the percent? So percent tells me it's out of 100, and then M over V. What are the units for M? What are the units for V? I have a volunteer. Jay? Somehow it just went forward. So we have grams over, what did you say? Okay, I'm halfway happy with that answer. What do we need to do to really make this useful? So in this case it's grams, so we'll do a generic one first. Grams of solute divided by okay. By writing out the units, we now just plug stuff in. What this question is trying to get us to say is, what's the relative ratio of mass of our solute in grams to volume of our solution in milliliters? So, what can we put on the top? What do we put on the bottom? Carmen?
Okay. We put 56.9 grams of KCl, potassium chloride.
Yep.
On the bottom you put 2,500 milliliters.
How'd you figure out 2,500 milliliters? I saw a lot of people putting 2.50 liters there.
I did that at first. But, I mean, after talking to her, I realized that I need to work.
So this is kind of a two-step process. I saw a lot of people trying to do dimensional analysis. This is not a dimensional analysis problem. We're making a conversion factor that we will use in dimensional analysis. This is not dimensional analysis itself. So I want to convert liters because I know I need milliliters of solution on the bottom. I need to figure out how many milliliters of solution do I have, what's the ratio. And our solute is KCl, so we can find that ratio. Are we done? If we just do that calculation, is that our percent?
No.
That's a fraction, but to find a percentage, we need to multiply it by 100. So, Tay, what did you have for your percentage on this one?
2.28.
Is that the right number of sig figs? 3 sig figs. Each of our starting values had 3 digits. So, that's great. Okay, if you were given a solution is 2.28% of KCl mass per volume, the first thing you should do is rewrite it in terms of the units that we had up here. How would I write that? If I was to take this and unpack it, the 2.28%, what would I rewrite that as to be a conversion factor, a useful conversion factor? Write it down on your own piece of paper. What would this be in a conversion factor? Remember what percent means. So we're going to have these units. What is this going to end up being with these units? I want to make sure we can go forwards and backwards. Does anyone want to volunteer to fill it in?
I might be wrong, but. Is that wrong?
All right, what do we think? So what Sam wrote up here was for every 100 milliliters of this solution, there's 2.28 grams of KCl. That's how you write this. So the calculations we did was to find this ratio, but when you see this number, what it's really hiding is that for every 100 milliliters, there's 2.28 grams of KCl. If you had 200 milliliters, it would be 4.56 grams. All right? So it's really about unpacking the units. And that's going to be the term we use for tonight. It's unpacking units, writing all the units, and then unpacking the units. Any question on how we got there? Is this like super easy, or are you guys lost? It's one or the other, I feel like, because everyone's really quiet. Let's do a little gauge. So far, thumbs up, confident, not so confident. What the hell are we doing? Okay, so we have a bit of mix. Let's do some practice. We're going to spend a lot of time, all class tonight is dedicated to working on this kind of stuff. So if you're not confident yet, hopefully we'll get there. So we're going to close that out. We're going to reopen it. And in this time, I want us to talk about the exact same solution, but I'm going to use a different set of units for concentration. I want to know what the molarity of this solution is. So just like we did the last one, go ahead and write out what are the units on the top, what are the units on the bottom, and then figure out what that ratio is.
But a mole is over a liter.
It's how many moles per 100?
Like, so would that not be right? It's a mole.
So it's two separate calculations. So the first one is to quantify.
Yeah,
And the second one is.
it was supposed to be that. But it can be over, just put it right around top of the liter.
It's two separate calculations because this looks like it's a.
It looks dimensionally.
It looks like you're doing dimensional analysis, but you're not. You're doing separate calculations. That's fine. So check with Tara and see if you
I
guys.
tried to
She did
separate
basically,
mine
she did
out.
basically the same thing. Yeah. Can't remember. Gosh, she actually, that's how I did it in class, and she actually managed to do it in dimensional as we did, I think she was showing her doing it. Maybe that's something different. Oh, no, one, it says, okay, so that. Four is literally the same question as two.
Okay, so what I did was I first found the molar mass of KCl, and then I used the molar mass of HCl to find the overall temperature.
Let's do another 30 seconds.
Because molarity is
These we get stuck on these. Or sit there.
Because if you look at that here, it says like solute is moles, solution is fluids. So molarity is just moles over liters, and because we found molars, how many moles of KCl at 56.9 grams per KCl, then we just put that over the liters and then we get the molar. And all the molarity means KCl over 1 liter. Liters are going to be on the bottom because it's moles over liters.
We got the same answer.
All right, let's walk through this one. Can someone help tell me what we're going to write as our units that we're trying to achieve to make this conversion factor of molarity? I get a volunteer. Donald. Great. Now can someone fill in the second half of that? Or do you want to continue?
I mean, again, it's moles of solute over solution, which is liters.
So in this case, our solute is KCl. So moles of KCl per liter of... Which one? Just keep throwing all the terms out there. What we're going to find is, it's always, in this class, we're always talking about per whatever of solution. What is the difference between all these terms? Are we comfortable with all these three terms? Talk to your neighbor, how do these three terms relate? Let's make sure we're all on the same page. Tell your neighbor how they relate.
I'll start with the solute. That is the salt that you force whatever.
solid sulfate is solid.
They pour it.
Generally, yeah. It would be, yeah, the liquid part that's not included in the solute. So for example, generally, water is a pretty common side.
So I will admit, I really like the hand gestures that one group has, so I'm going to ask for Jessica or Rebecca to share what the hand motions were.
You put the solute in the solvent and it makes the solution.
Great. So the solution describes everything mixed up together. That includes your solute, the thing that's dissolved, in the solvent, which is the thing that's in excess. Okay. So I want to make sure we're all on the same page before we start using these terms all day long. Okay. So I'm going to go ahead and erase that. So what we're looking for in this problem is we have to have the moles of KCl, and then we're going to divide that by the liters of solution. Do we have either of those yet?
No.
Before we do any calculations, you always say, do we have either of those yet?
We have the leader.
Yeah, we do. We have the liters of our solution. So then all we need to do is figure out the moles of our KCl. Can we do that? How do we do that, Maddie? Okay. $74 point. And I think it was 7.6, and you would include more digits. Whatever your calculator had, you'd use that for the next calculation. Taylor, do you have a question? Okay, great. So we know that you can use a molar mass to go from the weight of a substance to the number of moles, which is what we need in this conversion factor here. So now we have the second half of our unit of concentration. So if we calculate what that ratio is, question?
Could you set it up differently, like continued? You know?
Most likely no, but
Because I got the same answer, but I didn't do that.
okay, so here's one thing I want to try to suggest very strongly that you do. Whenever we have a question that's trying to find the concentration, start out just by writing units and then fill in, try to figure out how to get both of these things and find the ratio. If you do it, I saw a lot of people trying to do dimensional analysis and doing like multiple steps and then you equal, divide it by, it just gets really confusing. So sometimes it's really easy to get caught in the numbers and just try to like do too many things at once. So I would advise trying to write the two out, find each of them separately, and then just find the ratio. If you have another way that works and you're super confident in it, you can do that. But if it goes awry in an exam, it's probably going to be less chance for a partial credit if I can't follow the logic, if it's not like super clear. Dustin?
While you're getting the moles of the gram of the solute, or gram of, anyway, I just kept it at 3 significant fingers because that's what it started with. Will that give me the wrong answer in the long run?
So that is going to give us propagation of error. So what's going to happen is if you round here and then use the rounded number here, then you're throwing away certainty that you had, or you're throwing away accuracy. What you should always do is if you report an answer out, if I asked two questions, if I said how many moles of KCl are there, you would report out 0.763 moles. That's it. But if you have to do any more calculations, you would always use whatever the full value in your calculator is and then divide that by 2.50.
Okay.
So it depends on what you're doing with it. If you're reporting it out, you always report based on sig figs. If you use it anymore, don't use the rounded version. Always use the original version. Very good question. Okay, so what is the final value that we got here for this? Maddie, since you talked us through part of it, what did you get for your molarity? And the way that we say molarity is this big capitalized M. What I'm going to really be strong at suggesting is that once you see this, if you need to use this concentration for anything else, immediately unpack that M. So let's go ahead and do that. Go ahead and write out what this conversion factor now is. So write that beside. What is, if we unpack 0.305 big M, what does that actually mean? And think about the units that we had on the far left side.
We didn't unpack the M. Oh, take it backwards. That.
So what numbers are we going to put with those units is what I'm asking for. Okay. You want to answer this or you have a question? Okay. Shelby, what would you fill in for the top and the bottom here? Great. So the ratio is, this number here tells us how many moles there are of solute in every 1 liter of solution. That's what that big M stands for. What most people get stuck doing is they see this and they think that this is a quantity. This is not a quantity. This is a ratio. This is a conversion factor. Same thing with percent. It's a conversion factor. It's not a quantity. How does 0.305 compare to 0.763 over 2.50? What do you say, Chris?
It's the same concentration, but with it's just with a standardized volume, which is 1 liter.
Great. So it's the same exact ratio. If you divide 0.763 by 2.50, you're going to get 0.305 over 1. That ratio, that fraction, is the exact same numeric value. But whenever we say the molarity, we're going to base it off of, well, let's just use an easy number, 1 liter. How many moles exist in that 1 liter? That's it. Okay. Questions? We're super quiet tonight. Is it like too high energy? You have to keep it in?
Yes.
And that's not very useful, is it? Hiding. Okay. Go ahead and work on question 4. What is the percent volume to volume?
Why? Hold on, wait. What? What'd you get from doing that at the same time?
Okay, pause. Why is this not a great unit of concentration to use for this solution? Donald?
Grams instead of volume.
It's not a gas, so we can't use molar volume. So this unit, volume to volume, is something you use when you have 2 liquids.
Yes.
Or you might have 2 solids that are mixed together, but that's another more confusing aspect of the concentration. So for this type of solution, if we have a solid dissolved in a liquid, we're not going to use volume to volume ratio. We're going to do that when it's like drinking alcohol. So wine is 12% ethanol out of the entire solution. So we'll get to that in a minute. Okay? So let's look at another example here. So this is question 5, I think. So we do have an example of volume to volume.
Oh, we're nervous that one. I should raise the wrong one.
All that work for nothing.
You're using density of water, which is irrelevant for test before.
No, I actually typed it in.
You typed in the question. You have CHEM or something?
I don't know.
But I don't want to pay $15 for it.
I don't trust Chegg.
I think it's one of those sites for my history.
Dude, Chegg got so many things wrong, and a lot of my stuff, I don't trust Chegg anymore. I trust myself.
Why don't you use volume? Density.
Because it's a solid, and so the solid goes into water, so it's not have the same density because it disperses. Does that make sense?
Yeah.
If you have two liquids that are going together, then they're mixed together and they still kind of occupy similar spaces. There's some exceptions to that. So then you can do percent volume. What of the volume is that percent of the volume, right? But with that one, solid comes up totally different.
Thank you.
Cool. What's the other thing you can do? No, instead of converting both of them to milliliters.
Do you have to convert from milliliters to liters?
You just have to make sure they're in the same unit, both of them. So you can go either way. 23 responses. Let's do another 45 seconds. What?
Yeah.
Was that
In the I'm still in my notes, but I'm in my back.
Yeah.
Put it in the rail. I was too busy actually doing it. Put it in.
All right, we got 37 in. So can I get a new volunteer to give us the process for how we figure out this percentage? Dylan. Nice and loud so everyone in the back can hear you.
Okay. Well, I wrote down what I was given. 68.2 milliliters of acetic acid over 1.
And then what do you do with that?
And then another conversion factor, which is, I wrote down the also the, not conversion factor, but the 1 over 2.56 liters, what I put next to that.
You're writing them next to each other? What do you do with those?
Multiply.
Okay.
And then multiply 1 liter over 1,000 milliliters conversion factor.
So let's back it way up. So let's instead think about, before we write any numbers down, what are the units we're trying to get to?
Percent volume.
So volume percent, what are the units on the top, what are the units on the bottom?
Milliliter.
So we can do milliliters of solute per milliliters of solution. Is that the only option? Rakaya, what else could we do? Liters. Great. So volume to volume just says what is the volume of the solute dissolved in what volume of solution? As long as they're the same units, that's fine. We can compare them. So you can do either one of these. So in order to get this to work, we have to convert either the milliliters to liters, so they're both in liters, or the liters to milliliters, so they're both in milliliters. Either one is fine. So I think, off the top of my head, what's easier for me to do is to do milliliters. So 68.2 milliliters of our solute dissolved in 2,560 milliliters of our solution. There were a few people on our last exam who had forgotten how to do unit conversion with metric system. So if that did happen, please make sure that you practice. Go back and look at what your units are. I will continue to use them on the final exam as well. I'll use kilo, micro, milli, the ones that we've been using a lot. Okay, or I guess we could do 0.0682 liters per 2.56 liters of solution. Either way we do that, is that ratio done? What do we have to do? So because it's a percentage, we have to multiply either one of those by 100. And I think 2.66% is our final answer. Okay. So if we unpack those units, what does that mean? Go ahead and write it down. Do one more of these, and I think we're going to move on to applying these. What does 2.66% volume to volume mean? Question or answer? All right, hopefully most people have written this out. Go ahead, Courtney. What's the ratio that comes with this? Milliliters of solute. In this case, we're going to be more specific. We're going to do acetic acid. I'm not sure how well that shows up. Per. Great. Okay. So this may seem really boring at this point, but I guarantee you when you start working through these problems, the first thing that most people forget to do is they see this and then they don't know what to do with it. So every time you see a percent volume to volume, I want you to write this out. Every time you see molarity, I want you to write it out. Or percent mass to volume, whatever those are, always write it out. Shelby? Could you have written this in liters instead? Absolutely. Either one of them is fine. Honestly, after doing this, you could have done gallons to gallons. I don't care. As long as the ratio is right, that ratio applies as long as it's the same units on the top and the bottom. I would never want to use gallons, but, you know. Except when you're doing anything in the US, because gallons are so much smarter. So each time we've written out what those conversion factors are, let's go back to molarity for a second. What does this allow us to convert from and to? Olivia, can you say it nice and loud? Great. So from how many moles of solute you have to what volume it takes up in liters, or what else can you do with it? Flip it. So you can go from how many liters of solution you have to how many moles of solute that is. Either way. Each one of our conversion factors we have, just like molar mass allows us to go between weight and how many, these allow us to go from how much volume to how much it weighs or how many of them there are. Okay. So let's try to use some of these. So let's go ahead and figure out how much volume we would need. So we're at question number 6. Please write out your work. Think about any conversion factors we might have. Unpack conversion factors before you use them. Is that your starting quantity or conversion factor?
That's my conversion factor.
Great. So then think about what your starting quantity is, how you're going to use that conversion factor. Per liters of.
I was playing around and then messed up.
Careful.
I think you picked it.
So, first thing I want you to think of so, okay, I see where you're going with this. Before you do that, so I want you to rewrite this. Do that here. So here, what's going to be on top? Now that you have that, so you have the starting quantity you can use. So think about it. And then make sure that you're labeling everything together. What are you missing? So careful. Very first thing I want you to do is unpack that. What does that mean? 1.25 M. Of, what does the M mean? It's here. The very last one. Moles of what? Over. Okay, so that'd be 1.25 moles of ACL per what? 1 liter of solution. So that's your conversion factor. So now that you have a conversion factor, think about how you're going to use this conversion factor. It allows you to go from moles of HCl to volume or from volume to moles. So then reread the question, think about how you can use that, okay? How you doing? What are you calculating? From one of the later problems?
I can't type the letters. Okay, the last one.
First thing I want you to do is if you see a concentration, write it out. What does this mean? It's not an M, it really is hiding what?
It's the ratio.
So it's a ratio of 1 to what?
So it's moles of solid.
Moles of, in this case, HCl, that's for solute, per what?
0.25 moles of HCl over 100 milliliters of solution.
on the, oh,
Okay.
yeah.
So think about how you can use that
Okay.
conversion factor.
Okay.
Could you show me how you do this as a conversion factor instead of conversion factor?
No.
Okay. Let's see if we can actually do what we were talking about for a while before. We have 22 responses, so I'm guessing that this is not as easy
Wait, I'm not done.
when
Well, it's all
we're applying it.
I just submitted because I remembered that it was a clicker. I just remembered it was clicker.
Okay. How do we set this up? What is the first step that I've been trying to convince you all to do?
Convert.
Dustin?
Um,
Didn't you raise your hand?
I did, but I second guessed it. What was the question again?
What's the first step?
The first step that I did is I wrote what we know we're going to need to get to. So I wrote 0.570 moles of HCl over 1. And then I multiplied that by...
No, nope. Not what we multiply it by yet.
Oh, just kidding.
Sorry. So if we're going to do something, either we're saying like the bookends, what we're setting up as a dimensional analysis problem, or what I've been trying to beat into your guys' heads for the first half-hour class, 45 minutes of class. So do you want to do the bookends or do you want to do the unpacking?
I'll unpack it.
Okay.
It's 1.25 moles of HCl over 1 liter of solution.
Great. Okay. So if you don't do that first, then you see the 1.25 and you're like, is that my starting quantity? What do I do with that number? As soon as you write it out in this form, hopefully it's more clear that it's a conversion factor. It allows you to go from how much volume is how many moles, or how many moles is how much volume. So then, we're going to write out here, so Dustin started with what is our starting quantity, that's the rest of the information there. We need 0.57 moles of HCl. So then, what do we do?
So then I multiplied that by 1 liter of solution, of HCl solution, over 1.25 moles of HCl. Equals, well, I did the conversion of 1,000 milliliters over 1 liter in 1 thing.
Great. And I love that you did that all together. And then what did you find?
Yeah, 456 milliliters of solution.
Fantastic. Okay? So by doing it as a multiple step conversion, dimensional analysis, I love that. That's what I want to see you all doing. And we're identifying what our conversion factor is, ideally before you start using it. At least for the first couple of days we're doing this, I really want you to write out the conversion factor separate and then figure out which ones you need to use. All right. Phenomena. So in the clickers, just enter milliliters is fine. But I think as you're writing it out, it's nice to say milliliters of solution because it can be, especially if we have a liquid-liquid mixture, then it's milliliters. Milliliters of what? Chris?
Will there be a situation where you want us to specify like which solution, like HCl solution, or?
It never hurts to be more specific. So to say milliliters of the HCl solution would never be a bad thing. Sometimes we just start writing fast. There will be times where we're combining two different solutions, probably in your lab, maybe. And then how many milliliters of one solution versus how many milliliters of the other solution. Titration. All right. Good to go? All right. So let's go ahead and work another problem. As soon as you feel like you're stuck, ping people around you or flag one of us down. Just try to use this one a little bit quicker.
like to read so much.
So, first thing you're going to do is unpack your concentration. Go ahead and write conversion factor whenever you want. Just what does this mean? Just like we did. So that's one conversion factor you have. So now think about what is your starting point, what do you want to end with, or the other conversion factors might be. Is this a quantity? It's a conversion factor. So you never start your calculation with a conversion factor. You always start with quantity. That's a quantity. That's how it works.
So I can switch these?
Yep.
But it doesn't really. What you just said is the, don't start with 100.
Yeah, so I would start with that, convert it to the right unit, so you actually use this, and then think about it.
I see you're using the erasable pen as well. Yeah, the solution thing is yeah, I'm not the biggest fan of that. I think you didn't calculate the component inside. It's taken to the it's not trying to trade. Yeah, it's going to 6.5. Oh, the it's 106.5. But the process is correct.
So we only have 20 clicks. So if you have an answer and you haven't clicked it in, please do that. And if you're just waiting for me to work through it, don't do that. Alright, so remember the most important thing of active learning, which we're doing in class, is that you try, you struggle, you work through it, and then we resolve it afterwards. If you don't do that struggle part, it's so much less useful for you. So if you ever get stuck and you struggle, call one of us over. That's why so many of us are walking around. Please. Alright, we're at 33 clicks. So can I have a new volunteer, someone who hasn't talked yet today, talk to us? Jocelyn? Okay, so before we get Jocelyn talking us through the problem, who wants to talk through the one part that we're supposed to do before that? What are we supposed to do before we actually solve the problem? Julia?
So it would be 0.250 moles of KNO2 over 1 liter of solution.
Thank you, Julia. Okay, now we can go ahead. Pause. Did anyone add a little bit more? Or the terminology we used over here was just solution? So we could do KNO2 solution or whichever, it's fine. But we have to say it's volume of solution. Go ahead. Where did you get 1.25? Okay, that sounds a little better. Of solution. Okay. Grams of what? Over. I hear some discussion. Is there a different molar mass for potassium nitrite?
No, I think she might be right.
I heard multiple people say that though.
KCLO.
I think that's the same thing. From liters to grams? Oh wait, no, I'm looking at that. Okay. Ignore me.
Okay, so let's look at what she did for every single step here. She said, how much volume do we have in milliliters? But we know we're using molarity, so we have to get to liters at some point. So she converted from milliliters to liters in solution. And then for every 1 liter, this is how many moles of potassium nitrite we have. So she used the molarity to convert from how much volume to how many moles. But then I asked for grams, so we have to go from how many moles to how heavy it is in grams. And so what did you get for your answer on that, Jocelyn? Sebastian? What did you do differently? With the molarity? Okay, so this is something that I would say is a common setup that I really want to suggest we avoid. A lot of people will start with a conversion factor at the beginning of the problem. So remember that molarity is a conversion factor. We want a starting quantity. How much of it do we have? Not what's the ratio of moles to liters. Same thing like when we went from how heavy to how many. We'd start with grams or moles, and we'd go to another one. We use a conversion factor in the middle. So whenever we're doing these, always put your molarity or your percent volume or percent mass as a conversion factor down the line. Is that the difference? Is that you change the order of them? Okay. So I would very much, I saw this a number of times. It's a very common thing to do when you're starting out on this. Always put them kind of in the middle.
So is that correct?
So this is beautiful. And let's see where we're at with our clickers. Okay, it looks like we might have a lot of different ones. I did put, so you could put a unit in there, but y'all get the point. Okay, so let's talk about another form of application of this. So, saline bag in hospital.
I got a question. Why wouldn't the answer be grams of potassium nitrate?
Wasn't that what it was? Oh, you mean in the clicker?
Yeah, totally wrong.
Oh, I mean, that's an even better answer is grams of potassium nitrate,
Oh,
yes.
okay.
I just didn't see it in my list there, and I wanted to say grams. Sorry. So we have a saline bag. All saline bags are 0.9% sodium chloride. It doesn't say the units. This wasn't a chemist that printed this bag. So what do you think are the units? And maybe I'll even specify here. Let's do a couple more seconds to pick which one you think it might be. That's what happens. Okay. Okay, we have 42 responses. We have a mix. Let's think about the two things that are interacting with each other, sodium chloride and water. If we talk about how much sodium chloride we have, or are we going to talk about the volume of it, or the mass of it? What's a more appropriate way to talk about the amount of sodium chloride? Sodium chloride? A solid? You talk about the volume of a solid? Okay, maybe in cooking you're like, take 2 teaspoons of salt. Is that what we're thinking about?
Yes.
Okay. On an industrial scale, we weigh them out. So when we have something that's a salt, we're, for the most part, going to be talking about mass to volume ratio of the solution. We're going to say, how heavy is it? So let's then take that, and I want you to figure out what is the mass of sodium chloride in this 500 milliliter IV drip bag.
Why is my brain just not accepting any of this information right now? Like, I can't do any of this at all. Period. I need to be shown how to do it. I'm told to do it. Like, I
You've been told how to do it. You've gone through it.
I don't care. I don't care. I can't.
Your face is getting flushed.
I'm getting frustrated.
So the first thing to do is, what does 0.9% mean? If it's mass to volume, what does that actually mean? So like we did up here, remember we said, I don't know if you wrote it down, but we figured out 2.66%.
Yeah, it equals that over 100
Exactly. So do the same thing here. What are the units? 0.9, what? And then we can use that as a conversion factor. Okay, we're going to do 1 more minute at most for this, because we're about halfway through class, and I want to make sure we get through everything.
Halfway. Let's say, we have like a few minutes.
You rewrite your question. I do it every single time.
Right.
I don't know why.
Like, I'm like, my brain is just like,
I just worry that he's not going to get to start the problem until we have to do it. Every time I start, okay. Make sure you have it written down, at least the setup. Is that fair? Do you want to go through this and try one more before end of class?
please.
Okay.
Let's do like 10.
So what's hidden in here that we need to unpack? The percent. Shelby, you want to talk us through it? So what is What is the 0.9? So if we write it out, what's on top, what's on the bottom for a conversion factor? I can't hear you. Someone want to help out?
0.9 over 100.
Okay, 0.9 over 100, agreed. But let's add some units to make it mean something.
100 milliliters and 0.9 grams.
Okay, great. We're almost there. What are we missing?
Sodium chloride.
And? Okay, this number, 0.9%, means that for every 100 milliliters of solution, you have 0.9 grams of sodium chloride. Once you've written that out, does it become easier to answer this question? Would someone like to talk us through it? Quickly? Shelby, now?
So, after I got that number, I did 1. Yeah, I did, 500 milliliters.
I'm going to add solution to that.
Wait, I meant to put the 0.9 I thought it was added on to the first one. Wait, yes.
So we're going to do this dimensional analysis. So our starting point is the volume that we have. And then who would like to add a next step and help out? So which way do we need to use a conversion factor?
Oh, 0.9 grams of sodium chloride over 100 milliliters of solution. It would be for 4.5 grams of
And yeah, we'd want one more sig fig because we have
4.5
3 sig figs, although you could argue that's 1 sig fig. Okay.
That's it.
So the big take-home message for today is that conversion factors are hidden. The units are not there. If you write them out, hopefully it'll guide your calculations. We still have like 30 seconds. Right? Dang it. I just changed. Okay. Practice this a lot in your homework. We're going to do a few quick problems at the beginning of class on Monday. And then we're going to use these in stoichiometry. So now we're doing stoichiometry. Instead of starting with moles or grams, we're starting with volume of a solution. I will put that pre-class quiz up tonight or tomorrow morning for Monday.
Remember that one